Bismillahirrahmanirrahim. Today in our course of automotive technology, we will study chapter 8, that is our automatic transmission oblique transaxle principle. First, the basic slide of our course, the powertrain or power flow of a conventional rear-wheel drive vehicle. We have an engine where the power is developed. Then it goes to the flywheel. Then from flywheel, it goes to the clutch, gearbox, the transmission, the propeller shaft, differential box distributed to the right and the left wheel. Then we have studied brake, suspension, and steering topics. Now today's topic is automatic transmission. As we have discussed previously, if we have an automatic transmission or a transaxle, then power is developed from the engine. Then we have a clutch assembly, and clutch assembly, then it goes to the automatic transmission or transaxle. Then we have the left distribution and the right distribution. It goes to final drive and then to the right and left wheel. Now, brief or the basic part of an automatic transmission, how it looks like. First, we have this engine. From engine, the power is going from this your crankshaft to this flex plate. Power is going to this flex plate, and this flex plate is attached to the torque converter and specifically the impeller side. And impeller is on your transmission side. So this is on the outer side of this flex plate. We have starter ring gear. So this is a ring gear on which the starter pinion, the starter motor pinion is engaged when we ignite, do the ignition of a vehicle, or when we push start the vehicle. The starter pinion engages with this ring gear and try to drive the engine. So this is the torque converter assembly. In torque converter assembly, we have a impeller, stator, and turbine. Turbine is on the engine side, then we have a stator, and then we have an impeller. And that impeller is connected to the flex plate and the power coming from the crankshaft. And this is your converter housing. Then after this converter housing, we have this hydraulic pump or the front pump. And then this is the input shaft, which is going to the clutch packs. It may be a multi-plate clutch packs or different types of clutches which are there. Then we have a gearbox, and this type of a gearbox here, which we use in automatic transmission, it is known as compound or planetary gear set in simple. It is different than the conventional gear in which we have a synchro mesh and a gear arrangement. But here we have a planetary gear system. We will study later on in detail in this lecture. Then we have this complete housing of the body, and we have a shift lever, that oil pan and hydraulic valve assemblies. And then from this compound planetary gear sets, the shaft is going, that is the output shaft, and this is your extension housing, and this is your drive shaft or split yoke, which drive gives to the your wheels. So this is the basic layout of a automatic transmission of a vehicle. Now the major parts of an automatic transmission: the torque converter, the pump, planetary gear sets, multiple disc clutch, brake bands, overrunning clutch. So we will study all these in detail in our further slides. Now first, the most important part of our automatic transmission system is your torque converters. Now what is the purpose and function of the torque converter? The torque converter is located between the engine and the transmission oblique transaxle and performs the following function. So the torque converter is located between the engine and the transmission. In between it is located, and it performs following function. These are the three functions. First one is transmits and multiplies engine torque. It transmits and multiplies the engine torque. This is the first function. Second function acts as a clutch between the engine and the transmission oblique transaxle So second function in which it performs is to act as a clutch between the engine and the transmission oblique transaxle. Third functions is the allows slippage, which makes it possible for the transmission to be engaged in gear even when the vehicle and wheels are stopped. So it allows slippage, which makes it possible for the transmission to be engaged in gear even when the vehicle and wheels are stopped. So these are the three basic functions of the torque converter. Now let's study in detail the parts of the torque converter. As I have early here stated that there are three major parts of the torque converter. First one is the impeller, second is the turbine, and third is the stator. Before this start of this chapter, I have already uploaded two video clips. One is regarding the fluid coupling and second is the torque converter, the principal working of the torque converter. If you have seen those video clips, you must have a fair idea what I am talking about. Now, the first major part is that is the impeller. The impeller is the driving member and rotates with the engine and is located on the transmission side of the converter. If you see this figure, this is your engine, this is your torque converter, and impeller is on this side towards your transmission. So the impeller is the driving member and rotates with the engine and is located on the transmission side of the converter. The impeller inside the torque converter is also called the pump. So the impeller inside the torque converter is also called the pump, not to be confused with the pressure pumps which we are dealing daily in our life. So it is a different. Second major part of the torque converter is the turbine. The turbine is located on the engine side of the converter. So if this is your engine and this is the turbine on the engine side. The turbine is located on the engine side of the converter. The impeller vanes pick up fluid in the converter housing and directs it towards the turbine. Fluid flows drives the turbine. Fluid flow drives the turbine, and when the flows between the impeller and the turbine is adequate, the turbine rotates and turns the transmission input shaft because the turbine is linked with your transmission input shaft. As the impeller is linked with your engine crankshaft or drive shaft, the driving member, so the same goes for the turbine that it is linked with your transmission input shaft. So the turbine is located on the engine side of the converter. The impeller vanes pick up fluid in the converter housing and direct it towards the turbine. Fluid flow drives the turbine, and when the flow between the impeller and the turbine is adequate, is sufficient, the turbine rotates and turns the transmission input shaft. Now the third part is the stator. A torque converter also contains the stator. This is the or reactor, the third, which make it different from the fluid coupling because of the stator or the reactor, which is a reaction member mounted on a one-way clutch. We will see this thing. Now, again, a cutaway or model of a Chrysler PowerFleet two-speed automatic transmission used in 1950s. We have an engine on this side. Then we have this torque converter. And this torque converter, this is your impeller. This center portion is your stator, and this is your turbine. And then from turbine, this shaft is going here to the front pump and going to the clutch packs. From clutch packs, going to the planetary gear sets, and from planetary gear sets, it's going to the rear pump, which is used to drive the planetary gear system or the transmission or transaxle of the automatic vehicle. And this is your rear pump. This is the changing lever, the hydraulic valve assembly, and the oil pan here. So this is how the cutaway model of this Chrysler PowerFleet two-speed automatic transmission used in 1950s. Now again, diagram. Let's see this diagram. It's the one pump impeller from engine. So engine is on this side. and this is your flex plate, and the flex plate is attached to your impeller. Then second is this is your turbine runner to the axle, and this is third is your stator. This is your stator. Fourth is the front cover, which is on the engine side, and fifth is the lockup clutch. We will study in detail. Here we have this pump impeller, the turbine, the stator, and this is your the power input from the engine. This is your flex plate. It is attached to your impeller, and this turbine is attached to the power output shaft, and which is going to the transmission or the gearbox, a planetary gearbox system of the automatic transmission system. Now let's take a simple example of a two fans, pedestal fans. We have one fan which is powered and the second one which is non-powered. Two fans can be used to show how fluid or air in the case of a fans instead of automatic transmission fluid. So instead of fluid, we have a air, which is demonstrated here, can be used to transfer energy. So instead of a fluid which is transmitting energy in automatic transmission system, we are using air to transmit the energy from one fan to another. If one fan is operating, the blades of the second fan will be rotated by the flow of the air past the fan that is unplugged, causing the blades to rotate. So air, because air is this powered fan is pushing the air which is striking the blades of this unpowered or non-powered fan, and it will try to rotate the blades of this unpowered or non-powered fan. Now let's see this diagram. This is your impeller. Fluid is from these blades going to the turbine, striking the blades of the turbine, and coming from here center, the stator redirects the oil flow and going from the center and coming from the outer. A torque converter is made from three parts. The impeller is located at the transmission end. The impeller, it is the impeller which is located at the transmission end, but it is attached with the engine output. That is the crankshaft or the flex plate from where the power is coming. Attached to the housing and is driven by the engine. The turbine is located at the engine side. So this is on the engine side and is driven by the fluid flow from the impeller. So this is the fluid flow from the impeller which is driving this turbine, and the drives the input shaft of the transmission, which is there here in the input shaft of the transmission. The stator redirects the flow to improve the efficiency and multiply torque. So the basic function of the stator is redirect the flow and multiply the torque. Now, as in this case, we have a flow which is very turbulent here. So to reduce the turbulence, we use a split ring here, which in first when we have a turbulent fluid flow without this split ring, then we have a turbulence arrangement here, turbulence in the fluid flow. But when we use the split ring, then we have a smooth circulation of the fluid flow. The slip rings helps directs the flow of the fluid and improves the efficiency of the torque converter by reducing the turbulence which is in the fluid flow. Now, torque converter flex plate. The torque converter is typically bolted to a thin metal disc called flex plate. The center of the flex plate often has a pilot indentation for the nose of the converter. So this is the crankcase, and this is your flex plate, the brown one, and this is your impeller. This is your turbine. This portion is stator, and this green is your lockup clutch. The torque converter is typically bolted to a thin metal disc called flex plate. So torque converter is bolted to thin metal plate, which is in brown. This bolted here with the crankshaft and the torque converter. The center of the flex plate often also has a pilot indentation for the nose of the converter, the center of this flex plate, and the flex plate itself is bolted to the rear flange of the engine. And rear flange of the engine, the flex plate reduces the heavy flywheel used with the manual transmission. So basically this flex plate is in place of the conventional heavy flywheel which is used in the manual transmission. The torque converter bolts to the flex plate which is attached to the engine crankshaft and rotates at the engine speed. Now, torque converter flex plate, few more words about it. An important function of a flywheel is to smooth out engine pulsation and dampen vibration in a manual transmission vehicle. But an important function of a flywheel is to smooth out engine pulsation and dampen vibration. An automatic transmission does not require a conventional flywheel because the weight of the torque converter provides enough mass to dampen engine vibration. Because of the mass of the impeller, the turbine, the stator, and the fluid inside that torque converter, it gives a heavy mass. So that an automatic transmission does not require a conventional flywheel because the weight of the torque converter provides enough mass to dampen engine vibrations. An external ring gear generally attached to the outer rim of the flex plate, while on some application the ring gear may also be welded on the outer side of the torque converter. So an external ring gear generally attaches to the outer rim of the flex plate, while on some application the ring gear may also be welded to the outer side of the converter cover. What is the function of this ring gear which we are on the outer rim flex plate or the welded on the torque converter cover? This ring gear engages the starter motor pinion gear to turn the engine during starting. So same function as we have teeth on flywheel and the starter pinion starter motor pinion gear try to turn the heavy mass of the flywheel in conventional vehicles. So same goes here. This ring gears engages the starter motor pinion gear to turn the engine during starting. Some manufacturers also place the crankshaft position sensor tone ring in the outer lip of the flex plate. So in order to calibrate the engine timing, some manufacturer also place the crankshaft position sensor tone ring in the outer lip of the flex plate. This you have this torque converter, and this is the flat section that are cut into the hub of the torque converter are used to drive the fluid pump. These are the cuts which are used to drive the fluid pump. This figure, the internal splines inside the torque converter are connected to the splines on the stator shaft and the turbine splines to the input shaft. So this is the turbine shaft, the shaft coming from the turbine, and it attaches the planetary system. And this is the stator support shaft. We have a splines here, but this is the front seat. Torque converter operation, how it operates. Fluid sent to torque converter from the transmission oil pump is picked up by the rotating vanes of the impeller and transferred to the turbine vanes, which we have seen. Fluid coming from the transmission oil pumps coming here, going to the turbine outer blades and coming here from the center to the stator, changing the direction and multiply the torque and coming in the center and going from the outer. So fluid sent to the torque converter from the transmission oil pump is picked up by the rotating vanes of the impeller and transferred to the turbine vanes. The two types of fluid flow inside a torque converter are rotary flow and vortex flow. So there are two types of flow which are present inside the torque converter. One is the rotary flow and second is the vortex flow. Rotary flow is created by the rotation of the torque converter and causes the oil to flow around the circumference of the torque converter. So the rotary flow is created by the rotation of the torque converter and causes the oil to flow around the circumference of the torque converter, means on the outer boundaries. And the vortex flow is the flow of the fluid from the impeller to the turbine and back to the impeller. So the outer, which is on the circumference, that is the rotary flow, and the flow which is inside or not on the circumference, that is the vortex flow, and is the flow of the fluid from the impeller to the turbine and back to the impeller. So there are two types of flows in the torque converter. One is the rotary flow, which is on the circumferential of side of the torque converter, and the inner one is the vortex flow, which is going from impeller to the turbine and coming back to the impeller. Torque converter drives the pump. As we have seen, these are the flats which are drives the fluid pumps. The oil pump drive shaft generally passes through the converter inside a hollow input or transfer shaft and internally connected to the converter housing by splines or a hexagon shaped shaft. So the oil pump drive shaft generally passes through the converter inside the hollow input or transfer shaft and internally connected to the converter housing by splines or a hexagon-shaped shaft. The torque converter is also responsible for driving the transmission oil pump, sometimes called the front pump, because some early 1950s transmissions used a rear pump attached to the output shaft to allow the push starting of automatic transmission equipped vehicle. So we are having two pumps. One is the front pump and one is the rear pump. The torque converter is also responsible for driving the transmission oil pump, sometimes called the front pump, because some early 1950s transmission used a rear pump attached to the output shaft to allow push starting of the automatic transmission equipped vehicle. Now, how the torque multiplication occurs in torque converter. Now, the fluid leaving the turbine vanes strikes the concave or front side of the stator vanes. Fluid leaving the turbine vanes strikes the concave or front side of the stator vanes. The stator vanes changes the direction of the fluid. Number one, the stator vanes changes the direction of the fluid, pushes back side of the impeller vane. First, it is changing the direction of the fluid and pushes back side of the impeller vane. The stator redirects the fluid flow as it remains stationary during the torque multiplication. So the stator redirects the fluid flow as it remains stationary during the torque multiplication. So in first case, the stator redirects the fluid flow and it remains stationary during the torque multiplication. The stator hub mounts on a one-way clutch. So the stator hub, which is mounted on a one-way clutch, freewheeling in the clockwise direction, but locking when driven in a counterclockwise direction. So in one direction, it is freewheeling, and other direction, it is locking arrangement is there. We will see in our figure. When the fluid flows from the turbine strikes the concave face of the starter vane, it tries to drive the stator counterclockwise. By locking the stator, it can redirect the fluid back to the impeller. So when the fluid from the turbines strikes the concave face of the stator vane, it tries to drive the stator counterclockwise. By locking the stator, it can redirect the fluid back to the impeller. The force of the fluid redirects from the stator adds to the force of the fluid flowing to the impeller. So the force of the fluid redirected from the stator adds to the force of the fluid flowing to the impeller to increase the overall torque being transferred from the impeller to the turbine. This is called the torque multiplication phase. So the force of the fluid redirected from the stator head to the forces of the fluid flowing to the impeller to increase the overall torque being transferred from the impeller to the turbine. This is called torque multiplication phase. Let's see the figure. Stator not turning. So stator redirects forces like this. Torque multiplication, stator reversing oil flow from this turbine. The torque multiplication occur when fluid leaving the turbine strikes the front of the starter vane and is redirected back to the impeller. Now let's see this figure very carefully. A stator containing a one-way roller clutch which locks it from rotating in one direction and allows it rotating freely in the opposite direction. We know this is your stator assembly and this is your one-way roller clutch. If you see, we have these rollers here, and rollers are having a specific slot here. So here, when it is in this condition, the roller are stuck to this top, this position, it is locked. When the roller is in this position, it is freewheeling. So when roller are stuck to this spot, it is locked, and when it is in here, it is not locked, it is freewheeling. Torque multiplication phase. The torque multiplication occurs when the vortex flow makes a full cycle from the impeller to the turbine, through the stator and back to the impeller. So torque multiplication occurs whenever the vortex flow makes a full cycle from impeller to turbine, through the stator and back to the impeller. A torque converter multiplies torque in relation to the speed ratio. So a torque converter multiplies torque in relation to the speed ratio. At low speed ratios, the impeller engine speed is turning much faster than the turbine transmission input shaft speed. So vortex flow is high and torque multiplication occur. While at low speed ratios, the impeller means the engine speed is turning much faster than the turbine means the transmission input shaft speed. So vortex flow is high and torque multiplication occurs. As turbine speeds increases and approaches impeller speed, rotary flow increases, which reduces both vortex flow and torque multiplication. So when the turbine speed increases means transmission input shaft speed increases, and it approaches impeller speed means the engine speeds, the rotary flow increases, the circumferential flow increases, which reduces the both vortex flow, which is the inner flow, and the torque multiplication. As the speed ratio approaches 90%, means engine is rotating at, let's suppose, 100 RPM. So the turbine is rotating at 90 RPMs, means the 90%. The torque multiplication becomes minimal and the torque converter functions just like as fluid coupling. So as the speed increases or the ratio increases, it reaches to the 90%, the torque multiplication application becomes minimal and the torque converter functions like a fluid coupling. So this was the first part of our chapter 8, that is the automatic transmission and transaxle. We will cover the next part in our next slides. Kindly like my videos and thank you for watching.